response that firms have to changes in their demand for their product. Evan Jones? Evan here? Does anyone want to just try to articulate why it would be related to how the price changes when demand changes? Okay, no volunteers, so I'll just go through it. Okay, so imagine that there's a subsidy given to consumers, right? That's a natural way to increase their demand, right? You just give them an extra dollar for purchasing the product, they're going to want more of it, right? And we know that if there's $1 of subsidy given to consumers for purchasing the good, and $1 tax placed on producers for producing the good, the net effect of that can't be anything, right? Because it's just like moving money around. This is the classic result about the incidence of taxation being neutral to who exactly collects the tax, right? So what that means is that when the product is subsidized by $1 to the consumers and taxed by $1 to the producers, all that's going to happen is that the price is going to rise by exactly $1, but the quantity will stay the same, right? And what that means is that the amount that the price rises in response to the demand increase plus the amount that the price rises in response to the cost increase must be equal to 1. Right? So that's what's expressed in this result here. And note that we showed that the pass-through always has to be positive, because otherwise it would be infinite, essentially. And so what that means is that the pass-through of an increase in demand may actually be negative. If the demand for the product increases, the monopoly may actually reduce their price. So that might seem a bit counterintuitive, but it's really related to the point that we made earlier that even if a firm faces a competing product which reduces the amount that they would normally sell, reduces their demand function, that might actually lead them to increase their quantity, right? So the reason is monopolies' decisions are all determined by their demand function and what its shape looks like. And the demand function could increase, with a constant marginal cost function that wouldn't cause any change in price, right? But it might change the elasticity of demand, and that might cause the price to either go up or to go down. And so what this tells us is that the pass-through rate also determines how the monopolist responds to demand conditions. If the pass-through rate is high, you should expect that when demand increases, prices fall. When the pass-through is low, you should expect that when prices increase, when demand increases, prices will rise. And this has a very tight connection to what are called strategic complements and strategic substitutes. This is sort of another example of how, even though we're really looking at a monopoly model, it can help us think about what the effects of competition are. Because what does it really do to me when my competitor decreases their price? It basically increases the demand for my product. Sorry, decreases the demand for my product, right? Now, if that decrease in demand for my product leads me to want to lower my price, then I'm going to follow the price that my competitor charges. And that's going to be called strategic complements. On the other hand, if when my competitor lowers their price and that decreases my demand, that leads me to actually want to raise my price, then I'm going to do the opposite thing of what my rival does. And it's going to be what we call strategic substitutes. Okay. So to just give you a graphical sense of this a bit, what I've done is draw a few diagrams which indicate the effect that demand and cost shapes have on pass-through rates. So in all of these graphs, there's a change in marginal cost by a unit increment, and we're going to figure out how much that affects prices. Here's a concave demand curve, right? When we increase marginal cost by 1 unit, we move up its marginal revenue curve, but because it's concave, that has a relatively small effect on the price, and the price change is much smaller than the marginal cost. Here we've got a constant elasticity demand. A small change in the marginal cost moves us way along the marginal revenue curve and way up the demand curve, and so we get a price change that's twice as large as the marginal cost change. Here we have an increase. Here now I'm going to fix a linear demand curve, and if we have increasing marginal cost, then the pass-through rate is going to be smaller, and if we have a decreasing marginal cost, the pass-through rate is going to be larger. Now, note that we can also see the other results that we showed on this graph diagram. So the ratio of consumer to producer surplus is much smaller in the cases on the left where the pass-through rate is lower, right, than it is on the cases on the right where the pass-through rate is larger. Because here the profits are smaller, and so the ratio of consumer surplus to profits is larger. But we can also see another result, which I didn't have time to show you guys, which is that the ratio of deadweight loss to profits follows the same pattern. So when the pass-through rate is small, that ratio is relatively small. It's relatively large when the pass-through rate is large. You see that here as well. Okay. One last way to sort of think about why you get these connections is, basically the reason why a monopolist would have an incentive to pass through a cost shock a lot is that basically prior to the cost shock, she's basically indifferent over a range of prices. She'd sort of be happy to maybe charge less and go for, a bigger market but a smaller markup, or to charge more and go for a larger markup but a smaller market, right? In that case, a small change to her cost is going to break that indifference, and she's going to chase after, she's going to go after a much higher price, right? On the other hand, if the profit function is very concave about the optimum, if she's got a very clearly defined optimal price, then a small change in cost isn't going to change that by very much, right? Because it's all being given by the demand condition. And, of course, what is it that would cause monopolists to be tempted to charge a higher price or a lower price? Well, it's that there's a lot of inframarginal consumer surplus that you could get by charging the higher price, and a lot of deadweight loss that you could get by charging the lower price, right? And so we should very much expect that the deadweight loss and consumer surplus are going to be large whenever the pass-through rate is large, which is exactly what we just showed. Okay. So a natural question then is how can we actually measure some of these demand curves in the real world to figure out what they actually look like in practice? And one really easy way to do this, or not easy perhaps, but at least very effective, is to look on the internet. So there's just a ton of data on the internet, right? And a ton of transactions that go on, and a ton of people trying out lots of different things. And this gives us a lot of variation that might allow us to actually figure out what demand curves look like. So a particularly nice example of this is a recent paper by Laurent Aynav et al., which was on the reading list, where they looked at seller experimentation on eBay. So they got every transaction that eBay has had, basically ever, and they got all the information about them. And so what they were able to do is identify more than 500 occasions on which the seller of a good tried different ways of selling the good, at least 15 different ways of selling the good, maybe charging different prices at different times or even at the same time on different listings for an identical product. And then they tried to use this to figure out what the effects of changing auction terms or reserve prices in auction were on the demand for the product. Basically, what they did is take advantage of the fact that these sellers were themselves trying to learn the demand to allow us to actually learn the demand. Yeah?
How did they know that that's what sellers were doing?
Well, so they didn't know really that sellers were doing that, but what they did do is they tried out about 5 or 6 different definitions of what it would mean to be an experiment and made sure that all the results were robust across those.
But just because you vary the things on the right-hand side doesn't mean you get rid of the endogeneity bias, if there is one.
Yeah, so one natural, if you think about what could be endogeneity, you can say, well, maybe they're doing these different things. They think they'll catch some people in this market and some people in that market and whatever. But the thing is, there's about 5 different ways you can define an experiment. So you can only take things that are running at the same time. Or you can only take things that run at different times. Or you can only take things that run at the same time in different countries. Or whatever, right? And the point is that no matter how you cut it, you get the exact same result. And that seems to indicate pretty strongly that it is an experiment.
The right-hand side can be correlated with the error curve in all five in different ways that lead to a similar result. But you still haven't gotten rid of the endogeneity bias.
Look, that's true of everything, right? You could say that a randomized trial doesn't get rid of the endogeneity bias because there might be some secret correlation between the pseudo-random generator that you have and whatever. But I think we find it pretty compelling that if there are different things which would seem, if they have any endogeneity problem, to induce completely different types of correlation, all give the same answer. It seems to be pretty strong evidence, I think, that there's not a major endogeneity problem. So we can use variation in the reserve price, that is the minimum price that you have to pay in order for someone to win the auction, to measure something like a demand curve coming out of eBay auctions. Matt G, for G. Is Matthew G here? No. Does anyone want to try to explain why, what it means to have a demand curve in an auction based on the reserve price? No? Okay. Well, so the basic idea is that if you set a high reserve price, right, that means that you're not willing to accept less than a certain amount. That could make the price that you end up getting higher. Why? Well, imagine that the top bidder bids above the reserve price, but nobody else does. In that case, if you didn't have the reserve price at that level, the winning bidder would have paid what the second highest person had bid, and not the reserve price. So you can raise the revenue that you earn by charging the reserve price, right? Conditional on the good getting sold. But if the reserve price is above what the top person bids, then the good doesn't get sold at all. So that it also reduces the quantity that you sell, the expected quantity that you sell, if you raise the reserve price. So you can basically think that by choosing my reserve price, I'm choosing an expected price that I'm going to sell the good for, right? And that as I raise that expected price, I'm also reducing the probability with which I sell, right? And so that lets us draw out a demand curve in the auction. And in auctions, notice, basically the marginal cost has to be constant. Why is that? Because it's just the probability with which you sell the good, right? So whatever the cost of the good is, that's the marginal cost of selling it with a little higher probability. So the interesting thing is when Einov et al. Do this, they get this interesting non-monotone marginal revenue.